Everyone in this room has experienced Newton's first law. You turn a car to the left, your right shoulder hit the window if you're the passenger, right? Yeah, it's Newton's first law. Guess what? Newton's first law is for every object in motion will stay in motion, object at rest will stay at rest unless they act upon by another force. If I was teaching that traditionally, I would have given them the law first. We would talk about how they've experienced that law in their real life. And then we'll do some labs that show it. It's the exact same lesson I just did. All I did was change the order. So I did the labs first. We talked about how it relates to their lives. And then I gave them the law. I gave them the rationale behind it all. So they had to know it, even though they didn't know it. Or a lot of times they'll ask for information with not knowing exactly what they need. So if you're doing real life battleship, okay, if I have to, if we have to hit this thing that's 5 miles away, how do we have to aim the gun to do it? They may not know quadratics, gravitational pull, all that stuff. They're just going to ask, well, how do we know how to do it? Well, you could do some very simple stuff. Well, what if you went straight? Well, because they could throw a ball or something like that. And you start setting up, and they say, well, guess what, guys? This is really in math. This is some quadratic. This is this way. I was talking with someone who left. A lot of times, teachers forget when they design a PBL that their textbook is a resource. So she was talking about ways. Do you remember what the framework was? Because it was different ways to predict or something, wasn't it? And they could do graphs, they could do a bunch of tables and things like that.
Yes. Systems.
Thank you.
Yes.
Thank you. So what you can do is you can set up how ways to do something with systems with this. And then you can say, one of the questions might be, well, how can we predict this? Well, you know what, guys, we have a great resource right here in the class that might help us. So then they can go to the textbook and see, there's this whole chapter about this. One's on graphing, one's on this, one's on this. Okay, guys, let's look how graphing can do it. So then you teach them the lesson on the graphing. Does that help us get there? Maybe, maybe not. Well, what's the next one? Oh, it's doing table. Let's try that. So you're going through all the lessons, but you just put a frame around it. Does that help?
Yeah,
Maybe not a
I get it.
specific idea for that, but
What is another way to show us the other thing about this as well is that you codify your knowledge, and then the problem becomes a way to apply it within the real setting so that this knowledge then solidifies in a different way for students to be able to apply it into a real circumstance as well. And so that's another way of looking at where you position a problem within the continuum of the curriculum. Sure.
Right.
As well.
Right.
So,
Right.
for
And-
some things, it may serve better that way than the discovery method coming from the problem itself.
And I would say this, I would not recommend teaching every lesson via PBL. Not every topic is going to work with it. And also the amount of work, and the students are going to get burned out. Just like any teaching method. If you use the same method to teach every day, no matter what it is, they're going to burn out. I would do about one full-blown PBL unit, at the most 1.25.
Right.
At the most. Most likely, usually it's about one a semester. I was doing. Now, did I do a lot of the constructivist techniques throughout the year? Absolutely. But a full-blown PBL unit, I was doing 2 to 4 a year. So I wasn't trying to teach everything this way. So again, I kind of picked and chose my battles, with some things that lend themselves, like Newton's laws, lend themselves to a PBL very easily. Other things really didn't. So I didn't teach. So I would, have projects, I'd do other things, but I wouldn't try to teach everything via PBL.
And some teachers I know even will, one guy does occasionally a one-period PBL, start to finish in one period. But what he's trying to do his curriculum, he's also trying to teach them some of these skills, doing the know, need to know, the problem statement and so forth. And then when he's ready for this big PBL, they know how to do it,
Yeah, like I know someone that did a one-day, one-period PBL was, now she did it actually much more as a project, where it was after she had taught the Pythagorean theorem.
Right.
And she basically had a letter that the principal had gotten from a building inspector that said if all the corners of the room are 90 degrees, they'd have to shut that classroom down. And so the class had to determine if every corner was 90 degrees.
Yeah, man.
And what she hoped the students would do was grab meter sticks, do the measurement, see if a squared plus b squared equals c squared. Some of them forgot that they had learned Pythagorean theorem, and some said, well, can we go to the shop class and go get, you know, Carter squares and different things, and do protractors and things like that. And so they went outside of it to try to prove if the corners were 90 degrees. And it was interesting was that she shared that one student found that one was 91, so the classroom should be closed. Being 1 degree off, that's not 90, you know. So again, it was one lesson that was somewhat project-based more, I would say more of a project, because again, it was after the learning, but you can see the messiness in it, there wasn't one path. So I would think, you know, don't try to fit all of your curriculum into PBL. You know, kind of pick and choose with it a little bit. So a long answer to a very short question.
Yeah.
But it does kind of set us up for the next piece, actually, where we really want to take a look at one lesson. So we kind of talked about a whole problem versus a project, a big picture kind of thing. We really want to look at one lesson. So the next page that comes after that chart is, there's actually two lessons there. There's same material, there's just an A and a B. These tie into the water problem. So this is one of the learning activities that we would have done with the water problem that you guys experienced earlier today. What I'd like you to do is basically the exact same thing. Take a look at A, take a look at B, and then fill out that chart again. So there should be another chart on the next page afterwards. And really take a quick look at it and see who had the responsibility again. So if you were the student and experiencing this learning activity, who do you think had the responsibility for the question, for the procedure, how to share the information and analyze the questions?